We are asked to find the relationship between the angular velocity theta dot and the velocity s dot. We know that the total length of the string is L, and we can write L in terms of theta and s such that AQP is equal to L, which is a constant. So L is equal to AQ plus QP, where AQ is r theta and QP is s. So we can write L to be equal to r theta plus s. Here s is not a constant. Therefore, differentiating with respect to time, we get 0 as L is a constant equal to r theta dot plus s dot. Hence we can write s dot plus r theta dot to be equal to 0. Now we are asked to find the velocity of the contact point Q relative to O. As the point mass m moves towards the surface of the cylinder, the contact point Q moves in a uniformly curved path about the point O of radius r and angular velocity theta dot. Hence VQ is equal to r cap cross theta dot minus k cap. As we already took x-axis to be in the upward direction, therefore y is in this direction and z is into the paper. As theta is counterclockwise, theta dot is out of the paper and towards you. Therefore, we took the direction to be minus k cap, as this towards the viewer. Solving this, we get r theta dot to be equal to t cap. From A, we came to a conclusion that r theta dot is equal to minus s dot. Hence, we can write VQ relative to O to be equal to minus s dot t cap. In the question, it is said that the point Q is moving and we have to find the velocity of a particle relative to the moving Q. According to the diagram, P moves to M and Q moves downwards, and hence the relative displacement is delta r prime with respect to Q along the y-axis. P prime descends, say by delta s, and so P ascends by delta s. So at P we draw two vectors whose resultant would give us delta r prime, the relative displacement of P with respect to Q. We name them A and B, where B is equal to s delta theta along minus r cap, and A is equal to delta s minus t cap. Now A is a vector pointing towards Q, which means A is a displacement vector at Q relative to P, while we are interested in finding vectors relative to Q. To get this, we just need to change the sign of A as there is symmetry. So A, to get this, we just need to change the sign as there is symmetry. So A P with respect to Q is equal to minus of A. Now we can write delta R prime to be equal to B plus A of P with respect to Q. Therefore, this gives us B minus A. So we can write in place of B, we can write s delta theta minus r cap minus, in place of A, we can write delta s minus t cap. This gives us s delta theta minus r cap plus delta s t cap. Now we multiply and divide by delta t in the right hand side of the equation. So we get delta r prime is equal to s delta theta by delta t minus r cap plus delta s by delta t t cap and delta t. So the required velocity of the particle with respect to moving q is v prime, which is equal to s theta dot r cap plus s dot t cap. We are asked to find the particle's velocity relative to O when it is at P. So we know from the previous answers that V prime is equal to minus s theta dot r cap plus s dot t cap, and VQ is equal to r theta dot t cap. Now this is the velocity of point P with respect to Q, and this is the velocity of point Q with respect to O. Hence we can write an equation to bring out the nature of these velocities. We can write V P with respect to O is equal to velocity of P with respect to Q plus velocity of Q with respect to O. This is the easiest method to generate a vector relative to another. Here, q below and q above cancels out and gives us velocity of p with respect to O. Now we can write v is equal to v prime plus vq, which is minus s theta dot r cap plus s dot t cap plus r theta dot t cap, and we get minus s theta dot r cap, and s dot plus r theta dot is equal to 0, as this is the tangential velocity that we found to be 0 in the first question, question number A. So we know v is equal to minus s theta dot r cap. We are asked to find the component of acceleration relative to O of the particle along t cap. Now to find this, we must be in the q reference frame. In this frame, O seems to move vertically upwards as the particle swings towards the surface of the cylinder. You can see the markings on the diagram showing V, which is along minus r cap, and delta V, which is towards the y-axis, where delta V is an increment in the particle's velocity. From the diagram, you can see that the change in velocity along minus t cap is v delta theta. We can write this as minus t cap dot delta v is equal to v delta theta, which can be written as minus t cap dot delta v is equal to v theta dot delta t. So we want to find the acceleration of the particle with respect to O along t cap. Hence, we can write the dot product as t cap dot acceleration. Here, A is equal to delta v by delta t. Putting the value of delta v, which we just found, we get t cap dot minus v theta dot delta t by delta t. So we have a dot t cap to be minus v theta dot. And we know v is equal to minus s theta dot r cap. So magnitude of V is s theta dot, and putting in this equation A dot t cap is equal to minus of s theta dot times theta dot, which is equal to minus s theta dot whole square. And this is the acceleration of the particle along t cap. This is your answer.